Hey guys, welcome back to another installment of the Super Maslow series. In our last episode, I finished getting the meticulous Z-axis ready to be installed on the machine. The next step is to begin figuring out the chains for real. If you may remember from earlier in the series, I was struggling a little bit with figuring out how these chains would route. My biggest problem was that I had no way of securing the slack end of the chain. I was trying to figure out a way to attach it to the top beam, but it was running into a lot of trouble with that. The other problem I found was there was a spot in my bungees that clearly showed they were about to snap on me, so I wanted to move away from using bungees altogether. So for the chain, I realized that there's actually a quite simple solution to the problem here. I modified my XY motor brackets, these front plates here, to have this loop that comes up, as opposed to the original design, which didn't have that. It just mounted everything there. And then this loop actually gives me a little hole to run the chain through. So it comes along through here, and then I can secure that chain with a cotter pin coming this direction. That keeps the slack side of the chain all secured right there, and actually will give me a really good run of it along this whole section. The advantage of having this little design here is it means that I can just waterjet one of these plates. As for doing the chain routing and what to do about the bungee, I hadn't really done any work in CAD to kind of sort that out yet. While the frayed line displayed some reliability concerns for the original bungees, there's a fundamental engineering problem that actually just made me want to move away from them completely. This is because the stretchy nature of the bungee. It doesn't provide a consistent force on the slack side of the chain. At its most relaxed state, it's hardly putting any tension on the chain. This can lead to a slack side chain skip. On the other extreme, it's putting a large amount of force on the chain. If the force becomes greater than the force that's being put on the sled, then the motor gearbox is no longer reliably preloaded towards the sled, and any backlash in the gear train could be introduced into machine movements. This reduces the accuracy of the machine while those bungees are in that hyper-extended state. I could have drawn something up in CAD, but I had a general vision for where I wanted to go with it based on some discussions I had on the Maslow forums. The idea is to replace the bungees entirely with a counterweight system. This will consistently put the force of the counterweights on the slack chains and eliminate the variable force that the bungees give you. In order to route the counterweights, I will need to set up a series of pulleys to run them from the motors here all the way to the back of the machine and then down behind everything. Those pulleys I mentioned are just going to be two little pulley blocks I bought at a hardware store, and they'll have a little L bracket that'll cut with the motor mount brackets on the Waterjet cutter so that I can just mount them quickly and easily to the points in the frame that I need them to be at. To make the flat patterns for both sets of brackets, I'm using an Omax Waterjet cutter. This is an amazing, incredibly expensive piece of equipment. Using a stream of water, firing at approximately 40,000 psi, it mixes garnet abrasive to cut through virtually any material with outstanding precision. Here I'm just taking a sheet of galvanized steel and getting it prepped for actually cutting. The first thing to do is to make sure that it is secured in the machine, because there's a lot of back pressure that comes up. With that 40,000 psi coming down, there's equally that coming up. So that's what all those weights are there for, is to kind of hold the sheet in place and keep it from moving around too much. Once that's in place, I'm now just moving the head in and using a tiny little feeler gauge to get my nozzle standoff just right. I'm just checking to make sure that it's at the right height in a couple different places, and then I move the head over to its start position. Now that I've checked the height and I'm back to my origin again, it's time to start cutting. I'm going to flip down that splash guard, which is that little yellow cup, and now I'm just filling the tank up a little bit so that the cut is submerged in water. The water acts as a sound suppressor, and that keeps the cutting noise to a minimum. The first thing the machine's going to do is it's going to just fire a stream of the high pressure water without garnet. And what this does is it scores a line in the metal that I can use as a reference for bending later. Once it has scored all of those lines, it's now going to start firing through cuts. For this, you can see actually the cloud of garnet abrasive that's now getting mixed into the water. That's that brown sludge that you're seeing around everything. I'm also, now that I'm sure that it's cutting correctly, filling the tank up to its maximum level, which is what that bubbling that you saw in the background was there. That's just the water level coming out of the bladder in the back and filling up the tank entirely. I wish I could say it's a little bit more exciting to watch it actually work, but unfortunately, because the water level has to be so high, you kind of just see it slowly moving around in the tank here. So let's now jump ahead. It's now done cutting, and the first thing I'm doing is I'm retracting the Z-axis up out of the water and then commanding the entire gantry to move to the back of the machine so it's out of the way. I'm also going to start lowering the water level here just so that we can start to take a look at our parts. You can see everything that was in the tank is covered in a layer of that brown garnet abrasive. So you can see here the new brackets that I was talking about before. Now I'm just going to take the hose and rinse everything off and try to get all that garnet abrasive down into the bottom of the tank. This is a bit of a lengthy process sometimes, especially when you've got such a huge sheet in here. But the idea is that if you leave it sitting around for too long, it can kind of solidify into this concrete-like form. So that's the sheet clean now. I can unclamp it and pull it out. I'll need to take out the compressed air to kind of blow it off because this is all steel, so it will rust if it's left to sit here and be all wet. I'm not going crazy drying it off or anything, just enough to make it so it's not dripping all over the place. After that, I'm just going to wash these parts off real quick, and then I'll take the compressed air to dry them out. Again, don't want them to rust. Alright, so all these are bridged together in all these little spots here, just to keep it so that these little guys didn't fall down into my tank, because they can go between these slats, and when they go down there, they're gone forever. But they're so thin that you just bend them and they pop right off. And I try to only do like one point of contact to make it easy to just break them like this. So next I got to clean these up a little bit. So all I'm doing here is I'm cleaning up the edges a little bit. There's a small pointy bit of metal coming out from where that bridge that I just snapped came off of, so I have to take them all to the belt sander and just clean them up. I always try to place them near a corner or somewhere easy to blend into the rest of the piece, so it's a little less obvious. Alright, and now to the deburring station. With this Waterjet cutter, it leaves just a small fine burr on the back edge of the piece that you cut, so with everything that we do here in the shop, I always make sure to run them across a deburring wheel real quick, just to take that sharp edge off. It's enough that if you run your hand across it, it will cut you, so we make sure that that gets cleaned up. For one-offs like what I'm working on here, this is fine, but if we were doing larger sets of parts, let's even just say a quantity of 50 or something, we definitely want to throw this in a bead blaster or something where we can just kind of set it into a cabinet and do a whole batch of parts all at once. Those are deburred now. Well, the perimeters are. Alright, now for the finishing touches. So that deburring wheel did a great job of going around the edges of the parts, like I was just saying with the perimeters, but it didn't do any of the internal features. I'm using a combination of a countersink and a hand drill here, and that little deburring tool that you see in the foreground right now with the blue handle. That just has a little hook on a swivel that allows me to kind of just go around a hole or some more irregular shaped internal features, and it actually is sharp enough to just take that little bit of a sharp burr off the back. Okay, and now for the fun part. So this here is a press brake. It is a very, very powerful forming tool used to put very accurate bends in metal. A little over 90. What I'm doing here is I'm setting the bottom stroke of the press so that I can get a very consistent bend across all my parts. Still too much. This is a little bit of a fiddly process. That's better. But now that I have it all dialed in, what I can do is take each part and just line it up with that little score line that the Waterjet put on it, and just press down until it hits the bottom of its stroke, and each one will be the same size. The motor brackets are a little bit wider, I think, on the bend, so I had to adjust it just a little bit more just to get that bend to be right. And that's it. Alright, so I got a left mount, a right mount, and a whole bunch of little pulley angles. I hope these work the way I want them to. We'll see. Thanks for watching, everyone. I hope you enjoyed this installment. I know it's a little different than the last couple of them. I have a few more clips from the shop that I have lined up for our next episode. I'll catch you all later.